Let's talk a little bit about rounding. This seemingly simple mathematical skill can be quite complex to learn if we do not structure the learning in a way that helps students to make sense of the concept and understand why we might round in the first place. The history of rounding has been often to use rounding rhymes, tricks, and gimmicks. You might even be using these approaches yourself. I know I did. But I have long ditched the tricks, the rhymes, the gimmicks, the rules, and have moved to helping students and teachers how to conceptually understand rounding using an open number line. Before we look at how to teach rounding, let's talk about helping our students understand why we might round. Think about your everyday life. If you're like most people, you estimate much more than you calculate when you're working with numbers. Rounding helps us to quickly arrive at a number that's easy to work with. Nice round numbers, so that we can add or multiply or just estimate much more efficiently. When I travel, for example, I often round the distances to increments of miles or 10 miles so that I can use the total distance to do a quick calculation of time. When I buy groceries, I definitely just round to the nearest dollar for each item to get an estimate of the total so that there's no surprises at the cash register. When doing a long list of tasks, I often round to the nearest quarter hour for each task, and then I quickly group those into hours to estimate the total time that the list will take. Think about your classroom. When students are asked to calculate a solution in class, do they first do a quick estimate of the solution by rounding first? It doesn't seem to be the norm, but it should be. The reason that rounding occurs so early in our instructional school year is so that students can use rounding to determine the reasonableness of their solutions throughout the year. For students learning to round, understanding the relationships between the numbers is key. And by relationships, I mean understanding number sequence and the values that fall between numbers. That's why using a number line is a really effective tool when we're teaching rounding. All right, so let's begin with, say, a small number like 36. Our students already know that this number is one more than 35. It's one less than 37. They learned that in kindergarten. Kindergarten students also learned how to skip count by 10 and then perfected that in first grade. And that's going to come in handy when we begin to round. All right, so let's consider the number 36 and imagine we want to round it. We know 36. If we are rounding it to the nearest 10, there is a 3 in the tens place, and we won't consider the ones place at all because we're rounding to the nearest 10. So 30 would be the number. The first number is always easy because it will always be the same number that is in that place value. So if we're rounding to the nearest 10, we would go 10 greater than 30. 10 greater than 30 is 40. Our number falls between 30 and 40. Most of our students know that. The idea of rounding is, which is it closer to? So if we marked a midpoint, we'll call that the benchmark. If we mark a midpoint, would it fall to the right of that midpoint or to the left? Well, what is the midpoint? The midpoint is halfway. So if this leap is 10, halfway would be 5. 5 more than 30 is 35. Most of your students will probably already know that 35 is halfway between 30 and 40. Helping them to understand how to get there will help when they get to larger values. It's half of the leap. The leap is 10, so half would be 5. 5 more than 30 is 35. Now, does 36, is that number greater than our benchmark number of 35 or less than? We recognize that 36 is greater than 35, which makes it closer to 40, which means if we were to round 36 to the nearest 10, we would round to 40. Easy enough, right? All right, let's increase this. Instead of 36, let's make it 364. How about that? If we wanted to round 364, let's go again to the nearest 10. This is where it seems to be trickier for students. So I have a 6 in the tens place value. But I don't just have 6 tens. I actually have 36 tens. If I were to make the number 364 using just the 10 rods, I could build it using 36 10 rods and 4 single units. So on my number line, I have 36 tens and no ones would be my first value. Remember, we're rounding to the nearest tens, so I would want to go 10 higher than 360. 10 higher than 360 is 370. Or, instead of 36 tens, one more 10, 37 tens. We need our midpoint. So if this leap is 10, halfway would be a leap of 5. So what is 5 more than 360? 365 is our midpoint. And now we ask the question, is 364 to the left of our benchmark number, or less than, or is it to the right of our benchmark number, making it greater than? And in this case, we can see it is less than. 364 is less than our benchmark number, which makes it closer to 360. If we were to round 364 to the nearest 10, it would be rounded to 36 tens, or 360. Now, I know those of you who teach 4th and 5th grade, you're like, yeah, but my kids have to round much larger numbers. All right. Let's look at a really big number because the principle doesn't change at all. It's the same process. What do we want to round this one to? Let's say we're rounding this one to the nearest 10,000. We'll start easy. So we would have to know the ones, tens, hundreds, thousands, 10,000s. How many 10,000s do I have? 5. And then all of my other digits would be nice round zeros. So 50,000. If I'm rounding to the nearest 10,000, I would make a leap of 10,000. 10,000 more than 50,000. Or easier, if I have 5 10,000s and I make a leap to the next, I would have 6 10,000s, giving me 60,000. I'm rounding the numbers that are not the place value I'm targeting to nice round zeros. Just like before with the easier ones, we need to find our benchmark, our midpoint. If this leap is 10,000, half of that would be a 5,000 leap. So I would add 5,000 to 50,000, giving me 55,000 as my benchmark. I have 55,000s in my benchmark number, 52,000s in the target. Well, that is clearly less than 55,000s. So when I round, I will round to the nearest 10,000 by moving towards the 50,000, since 52,000 is closer to 50,000 than it is to 60,000. Here's something important for kids to understand. When we're rounding to the nearest 10,000, these are the only two options. The answer must be either 50,000, a little bit less, or 60,000, a little bit more. That's it. If 52,000 fell on a number line, these would be the two 10,000s that would be on either side. All right, let's do one more. What was our number? 813? Let's imagine that they were asked to round to the nearest thousands place. There are only two options that it will round to. So yes, I have a 2 in the thousands place, but remember, I have 52,000. It encompasses everything in front. So this number will be 52,000, and nice round numbers that follow the target place value. What would be 1,000 more than 52,000? Well, 53,000. Nice round numbers in the place value behind the target. You might have remembered that the next step is to find the benchmark. This is a leap of 1,000, so that makes this a leap of 500. If I add 500 to 52,000, I will get 52,500. This and this, 52,000, 53,000, are my only options. It can only be one of those two solutions. So when we use a number line, we help students narrow down their choices to just two choices. Well, 52,000 and my extras of 813, do I have more extras or less extras than my benchmark, my midpoint? My midpoint has 500 extras. You have 813 extras. You have more extras than the benchmark, so you will be to the right, where the numbers are greater, making you closer to 53,000 than to 52,000. Remember, these were the only two options. So give rounding on a number line a try, and then encourage your students to round every single day before a calculation. Just a quick mental calculation to approximate what they think the answer might be based upon the quick rounding that they did. All right, have fun with it.